This is SpaceTime, Series 28, Episode 96, for broadcast on the 11th of August 2025. Coming up on SpaceTime, a monster at the dawn of time. New data suggests Mars was even wetter than scientists thought. And NASA's plans to put nuclear reactors on the Moon and Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected the most distant black hole ever seen. This monster from the dawn of time, catalogued as Casper's Lidz 9, dates back some 13.3 billion years to a time when the universe was just 500 million years old, barely 3% of its current age. And just as surprising is the size of this supermassive black hole, which is some 300 million times the mass of our Sun. That raises questions about how it could have gotten so big so quickly, so early in the history of the universe. The findings, reported in the Astrophysical Journal, pushes back the boundaries of what current technology can detect, and it also provides a unique opportunity to study the structure and evolution of this enigmatic period of the cosmos. One of the study's authors, Steve Finkelstein from the University of Texas at Austin, says it's about as far back as you can practically go. He says, while astronomers have found a few more distant candidates, they're yet to find the very distinct spectroscopic signatures usually associated with a black hole. With spectroscopy, astronomers can split light into its many component wavelengths, allowing them to study an object's characteristics. To identify black holes, they first search for evidence of fast-moving gas. See, as it circles around the accretion disk of a black hole, light from the gas moving away from our point of view is stretched into the redder wavelengths, while at the same time, the gas on the other side of the disk, which appears to be moving towards our point of view, appears to be compressed, making it bluer in wavelength. Finkelstein and colleagues used data from the Webb Space Telescope's Casper's, that's Candle's Area Prism Epoch of Reionization, survey program. Launched back in 2021, the Webb Space Telescope provides the most far-reaching views of space ever achieved, and Casper's provides observations at its very outermost edge. Initially seen simply as an interesting speck in the program's imagery, Casper's Lidz 9 turned out to be part of a new class of galaxies which astronomers refer to simply as little red dots. Present only during the first 1.5 billion years of the universe's existence, these galaxies are very compact, red, and unexpectedly bright. Finkelstein says the discovery of little red dots was a major surprise from the early Webb data. That's because they look nothing like galaxies seen with the Hubble Space Telescope, Webb's visible light optical equivalent. So astronomers are now in the process figuring out exactly what they are and how they came to be. And Casper's Lidz 9 may well help astronomers do that. For one, this galaxy adds to mounting evidence that supermassive black holes are the source of the unexpected brightness in little red dots. Now, usually, that sort of brightness would indicate an abundance of stars in the galaxy. The thing is that little red dots exist at a time when such large numbers of stars is highly unlikely. On the other hand, feeding black holes also shine brightly. That's because they compress and heat the materials they're consuming, creating tremendous amounts of light and energy. So, by confirming the existence of a supermassive black hole in Casper's Lidz 9, astronomers have found a striking example of this connection in little red dots. The newfound galaxy and its central supermassive black hole may also help to answer what causes the distinct red colour in little red dots. That may be thanks to a thick cloud of gas surrounding the black hole, skewing its light into redder wavelengths as it passes through. At around 300 million solar masses, this black hole equates around half the mass of all the stars in the host galaxy. And even among supermassive black holes, that's especially big. Finding such a massive black hole so early on in the universe's history provides astronomers with a valuable opportunity to study how these objects have developed. See, the thing is, a black hole present closer to our time, later in the universe's evolution, has had a diverse range of opportunities to grow bigger. But one present in the first few 100 million years of the cosmos hasn't had that sort of time. And that's a huge mystery. Finkelstein says it adds to growing evidence that early black holes grew much faster than we thought possible. Alternatively, they simply started out more massive than our current models can predict. It's a fascinating puzzle. This is space-time. Still to come, new data suggests the red planet Mars was even wetter than scientists thought, and the United States announces plans to put nuclear reactors on the Moon and Mars. All that and more still to come on Space-Time. A new study of ancient Martian river systems is suggesting that the red planet was even wetter than scientists had previously thought. The new findings, presented to the Royal Astronomical Society's national meeting in Durham, are based on a close examination of more than 1,500 kilometres of ancient Martian riverbeds. The authors looked at fluvial sinuous ridges, also known as inverted channels, across Nochesterra, a region in the Martian southern highlands. These are believed to have formed as sediments deposited by rivers hardened and was later exposed as the surrounding material eroded. Similar ridges have been found across a range of terrains on Mars. Their presence suggests that flowing water was once widespread in this region, with precipitation being the most likely source of the water. The study's lead author Adam Luskut from the Open University says the findings indicate that surface water may well have been stable in Nochesterra during the Noche and Hesperian transition. That's a period of Martian geologic and climatic change around 3.7 billion years ago. Nochesterra has not been studied as extensively as other regions of Mars, in part because it contains very few valley networks, which are branching erosional features that have traditionally been used to infer historical rainfall and runoff. The study instead focuses on fluvial sinuous ridges as an alternative form of evidence for ancient surface water. Luskut says Nochesterra is a sort of time capsule, recording fundamental geological processes in a way that just isn't possible here on Earth. To reach their conclusions, Luskut and colleagues used data from 3 orbital instruments: the Context Camera, the Mars Orbiter Laser Altimeter, and the High-Resolution Imaging Science Experiment HiRISE. These datasets allow them to map the locations, lengths, and morphologies of ridge systems across a wide area of the red planet. Many of the features appear to be isolated ridge segments, while others form systems extending for hundreds of kilometres and rising tens of metres above the surrounding terrain. The broad distribution and form of these ridges suggest that they likely formed over geologically significant periods under relatively stable surface conditions. The spatial distribution and extent of these features all indicate that the water source was precipitation. Luskut says the work provides a new piece of evidence suggesting that Mars was once a much more complex and active planet than what it is today. The fact that these ridges form extensive interconnected systems suggests that the watery conditions must have been relatively stable for long periods of time. So these findings are challenging existing theories that Mars was generally always cold and dry, with a few valleys formed through ice sheet meltwater in sporadic short periods of warming. So a mostly warm wet Mars, as opposed to the freeze-dried desert we see today, all bodes well for the sort of environment in which ancient life, had it ever existed on the red planet, may well have thrived. This is Space-Time. Still to come, NASA to place nuclear reactors on the Moon and Mars, and later in the Science Report, new mRNA vaccine to target HIV/AIDS. All that and more still to come on Space-Time. The United States has announced plans to develop nuclear reactors to supply power to its future bases on the Moon and Mars. US Transportation Secretary and Acting NASA Chief Sean Duffy says the agency hopes to launch its first plant by the end of this decade. Duffy says NASA will appoint a nuclear power czar who will select 2 commercial proposals within the next 6 months. The move's being seen as an attempt by Washington to outflank plans for a joint Chinese-Russian lunar base by Beijing and the Kremlin, which is slated for construction in the early 2030s. NASA's been working on developing small, lightweight fission nuclear power systems since the year 2000. In fact, in 2001, NASA tested the SAFE-30 experimental space fusion reactor. It was one of a series of small experimental nuclear reactors developed by the agency for electricity production in space. Unlike solar power, nuclear reactors can operate continuously around the clock. That's a requirement needed in order to deal with the Moon's 15 Earth day-long nights and the red planet's thick dust storms. The power plant would need to produce at least 100 kilowatts in order to support long-term human operations, including in situ resource utilisation such as life support, communications, scientific equipment and the mining equipment needed to collect surface water ice. The current timeline would see the first reactor launched in late 2029, using a heavy-class lander capable of carrying at least 15 metric tons of mass. NASA's Artemis program will see humans return to lunar orbit aboard the Artemis 2 mission next year, with Artemis 3 landing a crew on the lunar South Pole in mid-2027. Duffy says the reactor's all part of a new space race against China. The ultimate goal is establishing a sustained human presence on the Moon. He says a future manned lunar base would need to be established at the Moon's South Pole, near permanently shadowed craters where water ice is thought to be abundant.
So this is not a new concept. This has been discussed under Trump 1, under Biden. But we are in the race. We're in a race to the Moon, in a race with China to the Moon. And to have a base on the Moon, we need energy. And some of the key locations on the Moon, we're going to get solar power. But this fission technology is critically important. And so we've spent hundreds of $millions studying, can we do it? We are now going to move beyond studying, and we have given direction to go, let's start to deploy our technology to move to actually make this a reality. And I think the stat we have is it's a 100 kilowatt output. That's the same amount of energy a 2,000 square foot home uses every 3.5 days. So we're not talking about massive technology. We're not launching this live. That's obviously, if you have any questions about that, no, we're not launching it live. But again, energy is important. And if we're going to be able to sustain life on the Moon to then go to Mars, this technology is critically important. And I would just note that we're behind, right? If we're going to engage in the race to the Moon and the race to Mars, we have to get our act together. We have to marshal all of our resources, all of our focus on going to the Moon, which is what we're going to do. And again, there's a lot of things that NASA does. And a lot of people love a lot of the things that NASA does. But this is about space exploration. And this is about this next phase. A lot of people don't know even what Artemis is. Everyone knew what Apollo was. We all knew, the whole world knew what Apollo was. We were going to the Moon. Artemis is we're going back. So in the first part of next year, we are going to send Artemis 2 out. Met the 4 astronauts. They're fantastic. We're going to go out around the Moon and come back. Artemis 3, we are going to go back to the Moon. We're going to land. The longest time we've spent in the past was 3 days. We're going to stay for 6 days. And then after that, we're able to start shipping our assets to the Moon unmanned. And we'll have those assets there as our astronauts arrive and are able to build a base. But this is critically important. There's a certain part of the Moon that everyone knows is the best. We have ice there. We have sunlight there. We want to get there first and claim that for America. And to do this is this part of the fission technology is critically important to sustain life, because solar won't do it, but it's just a lower amount of that fission technology that's going to allow human life to sustain.
That's Acting NASA Chief and US Transportation Secretary Sean Duffy. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have used mRNA technology to engineer new vaccines for HIV/AIDS, which have produced potent human responses to the virus in volunteers during early Phase 1 clinical trials. A report in the journal Science Translational Medicine claims using mRNA has allowed the authors to bypass common obstacles with HIV vaccines, and it's another step towards a more effective and affordable vaccine regimen. The human immunodeficiency virus HIV attacks the immune system, causing acquired immune deficiency syndrome or AIDS, which allows opportunistic diseases, normally easily combated by the body, to take hold, eventually killing the patient. The World Health Organization says that since first being diagnosed in 1981, AIDS has killed over 43 million people globally and infected more than 113 million. HIV is transmitted through body fluids. There is no cure, although it can be controlled using a combination of complex drug cocktails. Scientists have finally discovered the origins of potatoes, in the process solving a long-standing mystery. A report in the journal Cell claims the humble spud's DNA shows that it originally evolved from tomatoes around 9 million years ago in South America. The authors say natural interbreeding between tomato-like plants and potato-like plants triggered the formation of the tubers which we know and love today. Potatoes had proved puzzling because in appearance, modern potato plants are almost identical to 3 potato-like species from Chile called E. tuberosum, but those plants don't have any tubers. So, scientists analysed the genetic sequence of 450 cultivated potatoes as well as 56 wild potato species, finding they all contained a mix of genetic material from E. tuberosum and tomatoes. And that suggests that they must have resulted from the 2 plant species hybridising long ago. Developing tubers allowed potatoes to flourish because that allows reproduction without seeds or pollination, and it acts as a food storage for the plants, helping them survive in harsh environmental conditions. And this allowed potatoes to rapidly spread right across South and Central America. A new study has shown that cockatoos have up to 30 different dance moves in their repertoire, including headbanging and body rolls. The findings, reported in the journal PLOS ONE, follow anecdotal observations of numerous species of captive and pet cockatoos performing various dance moves, both with and without music. Scientists at Charles Sturt University identified 30 distinct dance movements, 17 of which had not previously been described scientifically. The thing is, dancing results from complex brain processes, including imitation, learning, and synchronized rhythmic movement. But spontaneous dancing in time to music has only ever been reported in humans and parrots, although many wild birds also display rhythmic movements as part of their courtship displays. However, as to what motivates captive birds to dance remains unclear. Maybe, like people, they just like it. A new study has found that people with lower cognitive abilities are more likely to be taken in by pseudoscientific claims. The findings, reported in the journal Applied Cognitive Psychology, are based on a meta-analysis study trying to determine why some people are more likely than others to believe statements which sound profound, deep and meaningful, but are essentially meaningless word salads. Tim Mendham from Australian Skeptics says the authors found that receptivity to this type of language is more common among individuals with lower cognitive abilities and greater faith in intuition, as well as a stronger belief in the paranormal, conspiracy theories, and religion.
People with limited cognitive abilities or lower cognitive abilities are supposed to be more prone to believing in those statements that are, shall we say, vague, claim a lot, don't make a lot of sense, are rubbish, meaningless. BS is the polite way of referring to them. These word salads of just putting words together and gee, it sounds impressive. That must be true because it's hard to understand. At one stage it was suggested, and we've spoken about this in other sort of discussions about people who are emotionally unstable are more inclined to believe because they're worried about the world. The world sort of has it in for them. But this is people with lower cognitive abilities. Doesn't necessarily mean dumb or stupid. We know a lot of people who are very bright. The issue here is the ability to do critical thinking, to use reason when you're assessing what someone else does. If you are unable to apply critical thinking to a statement that someone makes, you're less likely to be able to take it apart and see that doesn't make sense. I mean, literally doesn't make sense. Not that there's no evidence for it, not that it hasn't been proven. It's just that it's a garbage statement. It just sounds good. The sort of thing advertisers use all the time. Certainly a lot of mystics and a lot of people who are trying to portray themselves as deep thinkers and deep philosophers. And it sounds impressive because it uses big words and things. Critical thinking is something we do all the time, but we don't necessarily apply it everywhere. We apply critical thinking when we decide what sort of fridge to buy, what sort of car to buy, how you get from one place to another. You have to choose, you weigh up the evidence, weigh up and think, I will do this. When it comes to philosophies and religions and things like that, we do not use critical thinking. We use unreason to make our decisions. And that's what these things are relying on. These things sound impressive. They certainly have a bit of a religious, philosophical tone to them, these BS statements. Critical thinking, it comes down to, is the thing that skeptics push heavily. It doesn't matter what the answer is as long as you apply your critical thinking.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.